Okay, chapter 3.8, rates, ratios, and percents. There's an awful lot here. I'm going to try to move quickly. I'm trying not to confuse myself, and I'm going to try not to confuse you either. Rates, like unit rates. Unit rates are kind of cool, and it's something that you have to work with. And there's really just one really good way to do it. Say we have something like 37 inches, and we want to change it to feet. We're going to change it to feet, and we're going to multiply by a factor of 1. So we're going to multiply it by 1. For instance, we're going to multiply it by a fraction that means 1. Okay, and whenever we have something on the top, if we have 3 on the top and 3 on the bottom, that's equal to 1. If I have pi on the top and pi on the bottom, that's equal to 1. If I have 3 plus 2 on the top and 5 on the bottom, that's equal to 1. Okay, I think you see my point. We're going to multiply it by 1. We're going to make sure we multiply it by a factor that we can get what we want. We're changing it to feet. So we're going to multiply it by the number of inches in a foot. And so that's 12. 1 foot is 12 inches. Now I could have written it like this. I could have written 12 inches in 1 foot, but that wouldn't have done us any good, because we want to be able to multiply in such a way so that we are left with feet and have no inches left. So when I multiply by a unit rate, I need to make sure that my fraction has on the bottom of it whatever is on the top of the thing that I'm multiplying by, so that they cancel. Remember that if we have 3 1s times 2 thirds, the 3's cancel and we're left with 2 1s, or just 2. So we do the same thing here. Let's get rid of that. We want to cancel the inches, and we're left with feet then. And then when we multiply 37 times 1, it's 37 feet over 12. Okay, so then I just have to, figure out how many times 12 goes into 37. It goes in 3 times, and I'm left with 1/12. So 3 and 1/12 feet. Now I could figure out that means 3 feet 1 inch. I could have figured that out over here too. I probably could have done it in my head, but sometimes you have to understand how to do the unit analysis, and there's some complicated problems, and so it's important for you to just be able to do it. For instance, changing centimeters into meters, or say meters into centimeters. Say I have 3.2. Well, I don't know if I want to do decimals for this example. Say I just want to say 3 meters equals how many centimeters? Well, we're going to multiply by however many centimeters there are in a meter. Make sure that the meter is on the bottom so that they cancel. There's 100 centimeters in 1 meter. And so the meters cancel, and we're left with 300 centimeters over 1, which is just 300 centimeters. So sometimes it gets smaller when we go from a small object into a bigger object. We change from inches into feet. And 37 is a number larger than 3 and 1/12. But we're changing from something small into something big. We get fewer of them. In the second example, we do the opposite of that. We start with something larger and change it into something smaller, and we get more of them. But we're still multiplying. Either way, I used a dot here and an X here. I suppose that wasn't very consistent of me. But we're still multiplying. 3 meters times 100 centimeters over 1 meter. The meters cancel, and we're left with centimeters. And you can do this all day long. You can do it for hard things, like, say I have 13 cups, and I want to know how many pints there are. Well, I might have to look up in the back of the book to figure out that there are 2 cups in 1 pint. And oh, look at that, I did it wrong. I have the cups on the top, and I need to make sure that I have them on the bottom, or it doesn't cross out. So 1 pint is the same as 2 cups. This is my multiply by 1. The cups cancel, and I end up with 13 halves pints, and 2 goes into 13 6 with 1/2 left over. 6.5 pints. Pretty cool. That would be changing rates using unit analysis. So this is our rates. We'll go on to ratios. Using a ratio to write an equation. They give kind of a cool example about tulips. They say they tested 50 tulips out of 4,500. Okay, so you could write that 50 out of 4,500. They chose to write it differently. They wrote it 50 here, and they wrote it 4,500 here. And they say that out of that 50, they found that 32, so there were 32 tulips that were resistant to a natural resistance, so they're less likely to get diseases. So that means that there's going to be another 18 tulips that are likely to get diseases out of the 50 that they checked. And they say, well, how many is that out of our total? The total was 4,500 tulips. So this fraction should be equal to this fraction. Okay? 32 out of 50 is the same, it's equal to something out of 4,500. Okay, so we have to understand that, I'm looking at the way they did it there, multiply each side by 4,500. Oh, they wanted to get the x by itself. I see what they did. So they multiplied by 4,500 over 1 here, and they multiplied by 4,500 over 1 here. Okay, so these just cancel out, and it leaves them with an x. Leaves them with an x on one side of the equation. And then they have to do some work here. 5 goes into 45 9 times. Okay, so 5 goes into 450 90 times. So 4,500 divided by 90 is 50. So, or 50 times 90 is 4,500. So we're going to cancel these out. Changes into 90 over 1. And then 90 times 32. 9 times 3 is 27. 90 times 30 is 2,700, and 90 times 2 is 180. So 2880. So this is 2,880 is equal to x. So out of the whole batch of 4,500, there's going to be almost 3,000 that are resistant. That's more than half. I think that number makes sense. I think I did that right. 2,880 tulip bulbs that are resistant. If we were to do something really simple and we said something like, well, 3 out of 5 dentists prefer Crest as a toothpaste. Well, how many dentists prefer Crest? If we were to ask, how could we guess how many dentists were to prefer Crest if we asked 15 dentists? Now this one's easy. You can see right away that x is going to be 9. Okay, well, there's a couple of ways to do it. Way back in 5th and 6th grade, we just said multiply by 3 to get 15, so we'd multiply by 3 to get x, and x is equal to 9. If we did it the way that we just did it, back up a little bit here, we're going to do the same thing. We're going to multiply it by 15 over 1, and multiply it by 15 over 1, and these cancel. It's supposed to be a 1 here. 15 fifths is 3 ones, and we still get 9 equals x. Okay. There's also the cross products that you should have learned last year. Let's see if I can erase all this real quickly while I'm talking and not go too far. Cross products means 3 times 15 should be equal to 5 times x. So 3 times 15 is equal to 5x. And 3 times 15 is 45. Divide both sides by 5. 45 divided by 5 is 9. We already knew it was going to be 9, but I just showed you 3 different ways to solve a ratio. Okay. All right. Percents. Percents, I'm just going to give you the real standard percents. How do you work with percents? They're going to give you some story problems like 45% of a number like 280. Well, in our head we could say, well, 50% of 280 is 160. 160 is half of 280, so 50% of 280 is 160. So that gives us kind of a ballpark just to begin with. But we're going to use 45%. You can go 45 over 100 of always means times. Okay, so there we go. That's a pretty good start. We could figure out that 280 over 100 is the same as 28 over 10. Okay, and then we could just start multiplying or simplifying using what we know. Divide by 2. 45 over 10 is the same. Well, that doesn't divide by 2. We divide by 5. That's the same as 9 halves. And 28 halves is the same as, is that 14 ones? And 9 times 14 is, oh, don't need that one. 10 times 14 is 140. So 9 times 14 would be 136. No, 120. 136? 126 plus 14 is 36. 126. I think that's right. You guys can check me. Okay, if you feel like it, and you can tell me if I'm wrong, because most of the time kids love to do that. This looks bad. Rewrite it. 126. There we go. It's okay to use a calculator on this too. Another one that you definitely would use a calculator on is if you're going to change this to a decimal. Remember that 45% is the same as 0.45 times 280, and that's just a calculator. I guess I'll do it for you. 0.45. Let's clear this out. 0.45 times 280 equals 126. Looks like we did that right. 126 was our answer on a calculator, and it was our answer using fractions. Now, this is the way I'd always prefer. I love it if you can just figure it out on paper using fractions. Okay, bunch of stuff in here. I know this is probably a long video, but it's important stuff. Make sure that you're trying to figure it out. Do all the problems, and we'll talk about it in class. Here's a quick little picture for you. Let's start with the hair. What happens if I start with the hair? This guy has a mop of a head. Oh, we'll give him a little profile. Big nose. He's like, oh, you know what he looks like to me? He looks like a guy who's riding a surfboard. Yeah, I think so. Surfboard guys usually have long hairs. Long hair. There you go. Surfboard guy. And he's happy. And he's riding a Supermondo wave, dude. Alright. Totally cool. Talk to you later.